By now you know how to perform the basic operations on a batch system, and I hope you've been able to construct some large workloads to get real work done. But the next question we have to ask is, are you using the system efficiently, and how would we know? This matters to a lot of people. It matters to the end user, of course, because you want your workload to run as fast as possible. But it also matters to the owner of a cluster, who wants to make sure that everyone is served fairly and that the cluster is not wasted. A large cluster with a batch system has many different sources of performance data that you should be looking at regularly in order to understand how well your workload is running. It should have a system status display of some kind that should tell you how many people are using the system and how many resources and how it's divided up. There should be some queue status information so you can see which jobs are running, which jobs are waiting, and how long they've been waiting. There should be a job lifetime log that for any given job you can go in and see when did it start, when did it end, and how did it move around. And these logs can sometimes be hard to read, so we'll show you how you can submit these job logs to an online analyzer and get some more information. When debugging a performance problem in our local HT Condor pool, usually the system status display is the first place where I go, because it gives you a quick overview of how many people are using the system, what fraction of the system that they have, and what sort of jobs they're running, whether it's jobs that are one core each or jobs that are very fat using many cores, and so they might be a little more difficult to schedule. And so it's helpful to have this display easy to call up very quickly, because you can see very quickly, are you getting the number of resources that you expect to display? And if the answer is no, then you might dig into things a little more detail. The next thing is the job log file, which I introduced in a previous lecture. This is really an outstanding debugging tool because it gives you a very detailed description of the lifetime of the job. You know when it starts and you know when it ends, so you can figure out the execution time. If a job was evicted from machines and is bouncing around the pool, well, you're going to see that exactly in the job log. If there was something wrong with the job when it exited, you're going to see its status. And further, you should be able to verify by looking at this final record here that the execution time and the amount of data transfer matches your expectations. Now, if you like, you can take all of your records from all of your jobs and put them into the same job log file, and then it becomes a huge database of information. But the problem with that is once you have a million lines here, it becomes very difficult to understand and to pick out details of any individual job. So what we've done is we've created an online website that allows you to upload logs, and it automatically gives you some visual feedback of what's in that log. And the system is very easy to use. You go to condorlog.cse.nd.edu. You upload a file, choose whether you want it to be public or private, and the system will think for a little while, and then give you back a page that looks like this. And it summarizes everything that's going on in that job log file. So in this example here, we had over 6,000 jobs that ran for about 4 hours. And up at the top here, we have some summary numbers. So we can see the total amount of CPU time that we consumed was 60 days, 18 hours, and 22 minutes. Of that, 57 days, 9 hours, and 39 minutes was good put. That is, jobs that ran successfully to completion. Whereas 3 days, 8 hours, and 43 minutes was bad put. That is, jobs that ran for a while and then were evicted, and so they consumed CPU time but not productively. And then the elapsed time is 7 hours and 36 minutes from beginning to end. There were a total of 6,372 jobs submitted. And what's interesting here is it counts the number of execution events, which is the number of time a job starts. And you can see that there are 7,812 execution events. So that tells you a certain number of jobs started and then failed. If that number was extremely high, then we'd know there was a significant problem with eviction in the pool. And at the end of the day, the number of jobs completed is the same as number submitted, so that's good. Now, the green line in this graph shows the number of jobs currently running in the system. So the x-axis is time, and the y-axis on the right here is jobs running. So you can see that it starts at 0, goes up to about 300, and then bounces around for a while. Now, that variation in the middle comes from competition with other users. As you know, the system is very dynamic. Users come and users go, jobs get evicted, and so you can't count on having any specific number of machines available. But it's about 300 for most of the run. And then we see at the end here, there's a sharp drop off as jobs complete, and then we have a long tail. And the long tail happens whenever you have a distributed workload like this, because there's always some job at the end that got evicted at the last minute, has to be restarted, or a job that was simply longer than the others, or a job that got on a machine that was slow. So we always see this long tail, and then it ends after about 7 hours. You can also see the red line here is the number of jobs submitted and complete, and that's on the left axis here. So the interesting thing is it actually takes a good 3 hours just to submit 6,000 jobs, and then the complete line tracks that pretty closely until it gets to the end. Now, on the real website, you can scroll down quite a bit and get lots and lots more details, but I strongly recommend this as a way of understanding your workload to make sure that you're getting the performance that you expect.